everyone hear me? Perfect. Thank you very much. Very excited to be here to talk about DoubleZero and how we are rebuilding the internet for distributed systems. Before we get started, a little bit about me. I'm David McIntyre. I used to be at the Solana Foundation, where I worked in operations and finance. And about a year ago, I left to join DoubleZero as the COO of the DoubleZero Foundation. Previously worked in the fintech space, traditional tech space. So kind of seen a lot of examples of how companies operate and how companies grow and use systems and tools and processes to do that. So if you want to talk about that after the talk, more than happy to connect about ops, about how companies can grow and operate effectively. But I've been doing this for about a year at DoubleZero, and one of the things I've learned is that even though I have a year of experience learning about how the internet works, I really know absolutely nothing about it still. The internet is so complicated, networking is so in-depth, but one thing I have learned is that the public internet that we use to watch YouTube and do video calls, it really is not built for blockchains. It's not built for any high-performance distributed system at all. The internet, the public internet, is a general purpose technology, right? It's pretty good at a lot of things. But when you get to a certain scale, or you want a certain level of performance, it really doesn't do a great job. And the only solution to that is dedicated private fiber, which up until today has only been accessible to a select group of companies. And so what I mean by that is, when we look at Solana, right, this is a map from Solana Beach of all the Solana validators in the world, right? And all of the traffic that they are sending runs over the public internet today. And to be a validator, you need to be constantly talking to the other validators in the network. So if you're a validator sitting in Tokyo, you need to be sending data to all the other 1,000 validators in the world all the time. And all of that traffic is routed over the public internet. But the problem with the public internet is that it's designed to move data good enough and cheapest, right? So it's not going to pursue optimal routes for this data. It's going to deliver it as cheaply as it possibly can. And that makes it rather slow and inconsistent and crowded, the most important of which for Solana's purposes is inconsistent, right? So that's a concept in networking referred to as jitter. And jitter means the difference or the inconsistency in the speeds that you get when trying to send data from point A to point B. So when a Solana validator in Amsterdam wants to send data to Tokyo, they don't know how fast that's going to happen. And so that makes it very hard to design really optimized validators because you're not sure how fast you're going to be able to send data in and out. And you're also competing with all of the other traffic on the internet, like all of our video calls and stuff like that. So that's really a constraint that Solana as a network is going to face as it continues to grow and wants to be able to send more and more data, which I'll get into in a little bit. But big tech companies and financial firms, they have solved this problem. They have invested so much money in private fiber, in fiber that they control. And this is an article actually from earlier this year saying that Meta is going to be building the longest undersea fiber cable in the world. Meta, I didn't know this prior to starting at DoubleZero, but Meta has invested billions of dollars in laying down fiber all over the world because when you reach that scale, you realize that in order to continue to deliver these experiences that Meta wants to deliver, you have to control more of the stack. You can't just build software. You need to get involved with controlling the fiber because it's the only way to ensure that you're going to be able to deliver data in the speeds you need, the consistency that you need in order to maintain these experiences that you want. Gaming is another example of that, right? If you have millions of players all over the world, then if you're relying on the public internet entirely, it's going to be very hard to ensure that they all have a great experience, right? And so the problem with this is that these banks, trading firms, big tech companies, they lease and purchase this fiber, and they're the only ones who can use it. Right? Fiber is incredibly expensive, and when Meta does things like this, they're doing so because they will be able to run their traffic on it and nobody else will, right? And so that's where DoubleZero comes in, right? So what is DoubleZero? DoubleZero is a global physical fiber network that is purpose-built for high-performance distributed systems like blockchains and like Solana. So it's actually an alternative physical pathway for consensus, state propagation, and data delivery that uses technologies that are not available on the public internet. The best way I can kind of describe this is that we are building a Formula One track for a Formula One car. Instead of driving a Formula One car on a crowded highway that's rutted and you have to get off and go on a side road and go backwards and then get back on and you'll eventually get where you're going, but it's not built for that thing, right? And if it was, it would be a lot faster, a lot more efficient. So this is actually a map of the fiber network that we are building out. And we're going to be launching later this month, which I'll get into in a little bit. But these are physical fiber connections that have been added to the DoubleZero network by independent contributors, by 11 of them actually. And so you can see that they're connecting parts of the world where Solana validation takes place. And these lines are actually made up of a couple different components. One of them is the physical fiber. So you can see actually here, that's what an undersea fiber cable looks like. And so you have trading firms, investment firms, other companies that they have already paid for fiber. But fiber is so expensive to enable and install that they buy more than they need, right? Because if it's going to cost a ton of money to get access to fiber, then you're not just going to purchase the minimum that you actually need, you're going to purchase more, right? Because the startup costs are so high. But what that means is that a lot of companies are sitting on a lot of capacity that they aren't making use of, right? So it's a sunk cost for them. It's money that they've spent to enable this fiber, but they're not making any money from it, right? And so those companies can now contribute those connections to the DoubleZero network. The other piece of it is actually the hardware that sits on the ends of these fiber optic cables. And so we don't have time today to get into all of it, but there are devices called FPGAs which enable us to start implementing technologies that go beyond just a faster network, but actually provide much better performance for validators because validators are constantly bombarded by spam, right? So in order to be a profitable validator, you need to process valid transactions, right? But unfortunately, validators have to spend a lot of their time filtering out transactions that are not going to make them any money because they don't have signatures, because they're duplicates. And if we can actually take that load off of the validator and put it onto the hardware that's sitting on this network, we get to a place where it's not just reduced latency. So reduced latency meaning a faster network because we have this dedicated fiber, but also edge filtration, which I was just talking about. And then something called multicast, which is a technology that enables better communication of data through complex trees. So I was mentioning earlier that validators have to speak to all the other validators, right? And so right now, that's a pretty inefficient process because what can happen is a validator sitting in Singapore will be able to has to send data out to all the validators. And the way the system works today is they could send data from Singapore to Amsterdam, and then the validator in Amsterdam can send the data back to a different validator in Singapore. So the system doesn't understand that those validators in Singapore are actually located close together, right? But that's what multicast is. It's a way of improving that data transmission. It's the same technology actually that powers Sonos and AirPlay, those types of technologies for speakers, but it's not available on the public internet. It only works on private networks. And so that is an example, and this is actually a graphic of what they call the OSI stack, or the stack of technologies and computing systems, and you can see that blockchains like Solana, they really sit at the software layer, right? So running a validator client, for example, right? What DoubleZero is by bringing to bear this private fiber and these new technologies, you actually are improving the underlying physical and network layer of the network. And so why does any of this matter? Why is this important? I think there's a few really important reasons. Number one, we've heard today and in the past about this vision of internet capital markets for Solana. So the idea that Solana is the chain where hopefully we'll see a lot of traditional finance use cases replaced or improved upon. But for that to happen, right, you're talking about global scale. You're talking about way more demand for transactions than there are today. And when you start thinking about, we have these amazing improvements, Alpenglow and FireDancer. Alpenglow, which is the new consensus mechanism on Solana developed by Anza, and FireDancer, which is a second validator client, those are software improvements, right? But without an improvement of the hardware layer, we're not going to be able to reach the performance that those softwares can theoretically enable. And at the Accelerate conference earlier this year in New York, when Alpenglow was presented, Roger Wertheimer, the author of that paper, talked about how DoubleZero's multicast capability actually enables a lot of the functionality that Alpenglow is going to provide. The second thing is that if you look at this map from Solana Beach that I showed earlier, you notice that the validators are really clustered in specific places, right? Actually, most Solana validation happens in North America and Northern Europe. I was really surprised to learn when I started at DoubleZero that actually, I believe, over 50% of the stake on Solana is located in the triangle between London, Amsterdam, and Frankfurt. And that's where the internet is. And so, there's a lot of data centers there. There are network effects from being close to the rest of the validators. And so that's why you see these clusterings of validators, right? And you go down to Australia, there are no validators because it's not profitable to be a validator there because you're too far from the core. You're too far from the rest of the validators. And so therefore, you can't communicate with them effectively. And that's a really important part of being a profitable validator. And so what we can do is by bringing some of this connectivity, this faster connectivity to more places, we can actually now make it possible to be a validator in some of these southern locations where today we don't see any validators. And so that helps Solana obviously become more decentralized, be more global, and have participation from different parts of the globe where right now the internet is just not good enough to support that. And by providing faster connectivity, we kind of shorten that distance to the core, right? So those are a few things that are focused around the future and what we hope to be able to provide. Right now, we've been running our permission testnet since April, and we've been really pleased with the growth so far. We have 11 independent network contributors, so companies that have taken fiber that they have and given it over to the DoubleZero network, and some of their logos are displayed here. So you have companies like Galaxy, Jump, Rockaway X, right? These are investors, trading firms, VC firms. And Galaxy is a great example, right? Because Galaxy, they're an investor, they're a trading firm, they run their own validators. And so they see that by adding this fiber, not only can they potentially make money from it, because validators will pay to use DoubleZero and they'll be compensated in the form of rewards, but their own validators will also see an improvement in performance, right? So we're really excited about that. And the testnet that we've built, which is a more limited version of the DoubleZero network that I was showing before, we've already had over 220 Solana mainnet validators come to that network, which represent a little bit under 17% of the Solana mainnet stake. So these are validators who are taking their production profitable validator, their business basically, and they are using DoubleZero as an alternative to the public internet. Right? So they're connecting to DoubleZero to communicate to all of the rest of the validators and seeing performance improvements because now they're driving that Formula One car on a Formula One track, right? Instead of driving it over the public internet. And so it's really exciting to be here today because right now we're in the process of launching our mainnet beta this month. So launching the full network that I was showing that map earlier, really opening up high-performance networking for the first time. So instead of this world where only the biggest tech companies and financial firms have access to this private fiber because it's so expensive, now all the Solana validators in the world are going to be able to connect to this in a completely decentralized, permissionless way. And so we're really excited to see not just the performance improvements in Solana, but also potentially down the road other use cases, other chains, a lot of things that you can dream up because now we have this high performance network that's available to all instead of being available only to the select few. So that's my talk today. Really appreciate it. DoubleZero is a complicated thing, but hopefully I was able to share a little bit about it with you. And I think we have a couple of minutes for questions, so maybe we can open it up. I see a question back there, or yeah, wherever.
So what are your thoughts between fiber and free space optical communication, laser?
I don't know too much about laser communication. What I can tell you is that private fiber and fiber optics is a proven solution, right? Terrestrial fiber is not new. It's decades old. Michael Lewis wrote a book called Flash Boys, which is about high-frequency trading and making use of improved fiber. I like to think of DoubleZero as kind of marrying something proven and old, which is private fiber, with the new decentralized systems of today, like Solana. And in doing so, bringing the performance that other companies have seen into the blockchain space. So that's, I think, the best answer I can give about that.
Okay, so I think it was 220 or so validators you've got. There's good validators, there are bad validators.
Sure.
This is open and permissionless, so do you expect every validator to be running DoubleZero, or is it going to be gated in some way?
So to clarify, the testnet that we've been running to date has been permissioned, right? So you need to get whitelisted in order to use it. Now we're opening it up to all of the validators, and I think, hopefully we see, what we would love to see is validators using it sort of like Jito, right? Jito is a tool that's used by 85% of validators out there. I think a lot of people see it as like a table stakes feature for validators, like it's something that is really beneficial, and validators believe that they need to be using it in order to remain competitive. And so I think, hopefully what we believe is that, this is a dollars and cents conversation, right? What I've learned about validation is that validation is an incredibly competitive, low margin business. And so validators will use DoubleZero if they believe that they can make more money, if they believe that they can see improved performance. And so if that's the case, then we'll see uptick of usage, and that's our hope. Couple more back there. We have, one or two more minutes left.
Why does the location matter for profitability in terms of speed? Is that like add-ons, like them selling access to the read data, or?
Yeah, it's complicated, I would say. I think it has to do with, if you're located very physically close to other validators, it improves your communication and it improves your ability to ingest data faster. And so that's why you see, actually, I think the data center with the most validators in the world is located in Frankfurt, followed very closely by one in Amsterdam. I believe both run by TerraSwitch. And so, in that part of the world, validators benefit from being close together because it just improves their communication. Similar to if you're co-located in the same data center. So if you're in the same building as another validator, that gives you an edge, right? Like that gives you a faster communication than if you're located on the other side of town or across the world, just due to the physical distances involved. And so, complicated question, but I think that's why we've built, in that map I was showing, the biggest capacity of the DoubleZero network right now is in the places where Solana validation is biggest right now, right? That's where more connectivity is needed, more bandwidth, and that's where we've started.
You mentioned that big tech companies use the private networks because they're expensive and others can't afford it. Is that going to be different with this, where these validators are going to be able to utilize it at a lower cost, or are they going to be paying the big fees like the big tech companies?
Well, so yes, they're able to use it at a lower cost because the big tech companies have to pay for the fiber to be installed and lit up, right? That's where the expense comes from, and I think that's something that's really critical to understand about DoubleZero, is that these network contributors, they're the ones who are bearing the costs of installing and leasing this fiber, right? They're contributing it to DoubleZero because they believe that they can make money by adding their unused fiber to this network. And the reason that's the case is because they think that validators who will see improved performance would be willing to pay to use this network, but the cost to the validator is a fraction of what it costs to actually go and install your own fiber, which costs an enormous amount of money just because it's such a hard thing to do. I think we maybe have time for one or two more.
Does this only work for Solana, or could potentially other blockchains also say, hey, wait, we want to be able to plug into this this infrastructure you guys are building?
Yeah, that's our hope over time, for sure. Right now, it only works for Solana. That's something in networking referred to as multi-tenancy, basically running two pipes over this inside of the same pipe, right? And so definitely something that we're hoping to see down the line. We're having some conversations, but Solana is the leading high-performance blockchain in the world, right? And so I think we feel like this is the best place to sort of find product market fit to prove that this solution is effective, and definitely other chains and other types of use cases can come down the line. The 2Z token is the native token of DoubleZero, and it's a part of the network, right? So it's how contributors are compensated in the form of rewards, and it's how validators pay for the service. And so the mainnet beta is launching this month, and so the token is a part of that. I think we're almost out of time, but we could do a couple more questions.
Hey, David, that was a super cool talk. Wow. So kind of leaning on the other question of other blockchains, are you nervous that adding more chains to the network would slow it down, or is that not something that you guys are worried about?
I wouldn't say that we would be worried about it. I think that has to do with the bandwidth that's available, right? So most of the backbones of the DoubleZero networks are 100 gig connections. Some of them are 10 gig, and the planning of that and what contributors have contributed is based upon their impression of what the demand will be. And so I think it's hopefully one of these things where if there is a lot of demand, that's amazing because it means blockchains are growing and there's a lot of need for this service, and therefore contributors will contribute based upon that demand and that need because they see that there's an opportunity there. So I think it's something where we're launching a mainnet beta and we feel like there is more than enough capacity for what the network needs right now, and over time that's going to change because blockchains change and grow, and we'll see how that plays out.
In terms of like the difficulties in bringing on new or other validators, other blockchains, are you like dealing with tokens in the sense of like paying for services in the network? You're dealing with authentication into the raw sort of network itself, or are you building like an abstraction on top of like network packets organization that's specifically Solana based?
I'm not sure I fully understand your question. What I would say is the best way to think about it is like this is a validator. What they're doing is plugging into DoubleZero as a replacement of the public internet. And actually in the DoubleZero network, there's a fallback to the public internet. So if the DoubleZero network goes down, the validator can still go back and be using the public internet.
What I mean is it raw network packets, or are you routing like gRPC, like the actual, the higher level abstraction of the actual information data?
I don't know. I'll have to look into it and get back to you. We can chat afterwards for sure. But that's a good example of like, I'm not a network engineer, and network engineering is such a complex field, and there's some colleagues of mine who absolutely would be able to answer your question in 1 second. And it's incredible to learn about this space and the levels of complexity within it. Cool. Awesome. Well, really appreciate the time.